Hello students, I am Dr. NAVNEET Kaur, Associate Professor in Department of Electronics and Communication Engineering, Sagar Institute of Research and Technology College. Today I am taking my lecture on subject Signals and Systems. The topic of today's lecture is Classification of Systems. Now in this lecture I'll be discussing about the system and various types of systems and their properties. Now first we will discuss what is a system. Now system, it processes any input signal to produce output signal. It is actually a combination of elements that manipulates one or more signals to accomplish a function and produces some output. Now, in this figure, we can see the system is a unit in which input signal is given and output signal is generated. Now, system is used to perform some specific operation on any signal, let it be discrete time or continuous time signal. Now, in this figure, we can see that this processing unit is a discrete time system in which input xn or xt is given. Xn is the discrete input and xt is the input to the continuous time system. Now, this input is known as excitation also. Now, when this input is given to the system, the output generated is also known as response. Now, here the output is donated by Yn if it is in the case of a discrete time system, or Yt when it is a continuous time system. Now, regarding the notation of the input-output relationship for the system, we can write xn when given to the system, it will generate yn. So it will be xn arrow t yn, where t is the operating function which operates on any input, and as a result, the output is generated. So t is also known as transformation operation. Now, similarly for continuous time system, we can write xt when it is operated by this operation unit t, it will give yt. Now, the most common example is of a system is a filter. Now, if we have any signal which contains noise, it is applied to the input of the filter. Now, this signal which is mixed with noise is an input signal to the system. Now, the filter, it attenuates noise signal. That means it processes the signal and removes the noise. So, at the output, we will get a noise-free signal, which is also known as the response of the system. Now, coming to the classification of system, we have 6 types of classification. Now, first we have a causal and anti-causal system, linear and non-linear system, time variant and time invariant system, stable and unstable system, static and dynamic system, invertible and inverse system. Now we will discuss some of these classification of the systems. Now first we have causal and anti-causal system. Now a system is said to be causal if the present value of the output signal depends only on the present or past value of the input signal. It does not depend on the future value of the input signal. Now here we can see an example of any system in which yn, which is the output, is equal to xn plus 1 by 2, xn minus 1, where xn is the present input to the system. Now here we can see that the output depends only on the present input or past inputs. It does not depend upon the future inputs. So this is the causal system. Whereas anti-causal system, in this case, the present value of the output signal depends on the future value of the input signal also. Now, like we have a system whose equation is given by yn is equal to xn plus 1 plus 1 by 2 xn minus 1. Now, xn plus 1 is the future value of the input signal. So this system is a anti-causal system. Now coming to the next property, which is linear or non-linear system. Now linear system is a system which follows the superposition principle. Now suppose we have any system which is defined by the transformation operation T, and input x1n is given to the system, it will generate y1n, and when x2n is given to the system, it will generate y2n. Now if I will multiply input x1 with a1, the output should be a1 into y1n. And if input is multiplied by, say, some other constant a2, then output will also be multiplied by a2. Now, if I will add a1x1n plus and a2x2n and then give to the particular system, now in that case, the corresponding outputs will also be added. Now, this theorem is known as superposition theorem. Now, according to the superposition theorem, a1x1n plus a2x2n, when operated by this system, it will give a1 into x output of the x1n plus a2 into output of the x2n. So this will define superposition principle. Now, if a system satisfies this superposition theorem, then the system is known as linear system. Now, we will understand the property of this system with the help of an example. Now, suppose if I want to check a system which is given by this equation yn is equal to nxn for linearity. Now, here say I'll consider two inputs x1n and x2n. Now, if x1n is given, then the output should be nx1n. And if x2n is given to the system, the output should be nx2n. Now, if I add these two inputs nx1n plus nx2n and give to the system, I will get nx1n plus nx2n as the corresponding output. Now, if I add x1n and x2n and then add this to the system, then according to the property of the system, the particular input will be multiplied by n. So the output will be this. Now, if I compare these two outputs are exactly similar. So here y dash n is equal to y double dash n. So I'll say the superposition theorem is satisfied. So the given system is a linear system. Now, coming to the next system, which is time variant or time invariant system. Now, if the input-output characteristics of the system do not change with time, then in that case, the system is known as time invariant, and otherwise it is said to be time variant system. Now, consider a system in which input is given xn and output yn is generated. Now, if I delay xn by k samples, then I will get xn minus k, and then I will give it to the system. Then in that case, the output should not change. It should be only delayed by the same amount k. That means the characteristics of the system does not change with time. If there is a shift in the input, then there will be shift in the output. Then in that case, the system is known as time invariant system. Now, if xn is given to the system yn, and yn is delayed by k samples, then yn minus k will be generated. Now, if this yn minus k is equal to this yn comma k, that means there is no change in the input-output characteristics of the system. So the system will be known as time invariant system. And if this property is not satisfied, then the system will be known as time variant system. Now, we have given the property in the form of steps. Now, first we will delay the input by k samples and then give it to the system. The output will be yn comma k. Now, in step 2, if I'll give xn and I'll get yn, and then I'll delay this yn, it will be yn minus k. Now, if these two values of output are same, then system is time invariant. Now, I'll understand it with the help of an example. Now, suppose I want to check this particular system, which is yn is equal to xn minus 2 with the help of an example, with the help of the property of this time invariant. Now, I'll delay input by k samples. Now, in that case, the input will be now xn minus k. And I'll give it to the system. The output will be yn comma k. Now, according to the property of the system, I will get xn minus k minus xn minus k minus 2. So, here is the output. Now, in step 2, I'll give input xn to the system and I'll get output yn. Now, yn as given by the property of the system is xn minus 2. Now, if I give this output to a delay unit, which will delay it by k units, then I will get xn minus k minus xn minus k minus 2. That means wherever there is n, it will be delayed, then that means I'll write n minus k. Now, in that case, yn minus k will be xn minus k minus xn minus k minus 2. Now, if I'll compare these two outputs, I will see that yn comma k is equal to yn minus k. So, system is a time invariant system. Now, I'll take a second example where xn plus n xn minus 2 is the output of a system. Now, if I'll delay xn by k units, I'll get xn minus k. And then I'll give it to the system, then yn comma k will be xn minus k plus n xn minus k minus 2. That means in this input function is now in the terms of n minus k. Now, here it will be n minus k minus 2. Now, if I'll give xn to our input system, I'll get yn like this. But if I'll delay yn by k units, now wherever there is n, here it will be n minus k. So I'll get this as yn minus k. Now, if I'll compare these two, it is obvious that these two outputs are not equal. That means system is not time invariant, wherever system is a time variant system. Now, coming to static or dynamic system. Static system is a system in which output at any instant of time depends only on input samples at the same time. That means, example, yn is equal to 9xn. That means output at instant n depends only at the input at instant n. Now, if I'll write yn is depends on x 2n plus 8xn plus 17. Now, this is also an example of a static system because here output at instant n depends only on the input at instant n. Now, if I'll take the case of a dynamic system is a system in which output at any instant of time depends on the input sample at the same time as well as at past or future times also. Now, so here if I'll get a term xn minus k, that means there is a contribution of the past input signal. And if I have xn plus k, that means there is a contribution of future signal also. So in that case, the system will be known as dynamic system. Now I'll see the example where yn is xn plus 6xn minus 2. Here output depends on the past input. So this system is dynamic. Similarly, for this system, yn is equal to 4xn plus 7 plus xn. Here output depends on the future input. So system is a dynamic system. So the dynamic system should have a memory because it needs a memory to store samples, even past or future input sample. So dynamic system is defined by a memory. So this is all for today's lecture. Thank you.